In this tutorial, I'll be giving you a clear and direct guide to implementing the ScopedModel architecture in Flutter. My name is Dane from FullStacks, and today we are setting up a ScopedModel architecture that is maintainable, easy to understand, and caters to building more than the small apps it's been thrown towards. At the core, ScopedModel is a set of libraries that rebuilds its children that depend on the model when the model properties are updated. There are two main ways to implement ScopedModel, and there's also one hybrid approach. All the implementations only collect data to reduce state for the views, and all the functionality is handled by the dedicated services. For the first implementation, you have one app model that is extended with additional functionality models. The app model is extended through mixins that encompass all the logic for a specific feature. The functionality models will be things like an authentication model, a user model, and an information model. This one model is passed to every descendant child that requires it. For the second implementation, you have a scoped model per view or widget. Each view depends on only its scoped model. This approach requires more files but keeps the complexity of the scoped model limited to its views only. For this guide, we'll be implementing the scoped model architecture using one scoped model per view. The way we'll set up the architecture is as follows. Each view will have a root scoped model widget and will be passed an instance of the associated model when the widget is built. The model will be retrieved through a locator setup using getIt, and the services will also be injected into the model using the locator. With that said, let's start coding. One quick thing, please subscribe to this YouTube channel and activate your notifications. Create a new Flutter project called Scoped Guide and open it up in Visual Studio Code. Remove all the comments and the home page classes and return a container as your home widget. Go to your pubspec file and add the following dependencies. ScopedModel 1.0.1 for our ScopedModel widgets, and for dependency injection we'll add getIt 1.0.3. Let's start by setting up our service locator. In the root of the lib folder, create a new file called service locator. Import the getIt package and create a new instance of getIt called locator. We'll also set up an empty function called setupLocator. This is where we'll register all our services and models. Go to the main file and import the service locator. Before we call run app, we'll set up our locator. Now let's add the home view and its associated scoped model. Create a new folder called UI under the lib folder, and under that folder create a new file called home view. We'll import the material package, and we'll also import the scoped model package. Then we'll create a stateless widget called home view. Since each view has an associated scoped model, we'll return the scoped model widget as the root view, giving it a type of home model. Set the child of the scoped model widget to an empty scaffold. Now we can create our scoped model. In the lib folder, create a new folder called scoped models. And under that folder, create a new file called home model. Import the scoped model package. Create a new class called home model that extends the model. Model is the base class for all scoped models. Go to the service locator and register the home model. We'll register our home model as a factory so that every time we request a type of home model, we get a new instance back. Remember to import the file. Back in the home view, we can now supply our scoped model with the model that it requires. Import the service locator and use the locator to get the home model type. Locator can be called as a function, so we'll just call locator, give it a type of home model, and put the parentheses behind it. Then to complete up the scoped model setup, we will wrap our scaffold in a scoped model descendant widget of type home model. We'll change our child property to builder and supply it with a builder function. The scoped model descendant builder function sends back our build context, a static child, and our scoped model. And then for the body of the scaffold, we'll place some text in the center of the screen. We'll get this text from the model and we'll call it title. Then go to your home model and create the title property and return a constant string. Go to the main file and change the home property of your material app to return a home view. Just to check that everything's working, just run the app and you should see the home model string in the center of your screen. Next up, we'll tackle services. Create a new folder under lib called services, and in that folder create a new file called storage service. We'll add a feature that will simulate saving our data. So add a feature that returns a boolean called save data. Make it async, and we'll make it wait for 2 seconds and then return true at the end. Services will also be provided through the locator. So open up the service locator file and we'll register a lazy singleton. What this means is that there will only be one instance of storage service, but it will only be created once the storage service is required for the first time. With this architecture setup, the services will be doing all the actual work. The models will only be used to update state for the UI. What that means in code is that the functions called on the model will always call the functions on the services, and based on the result returned, it will update the state accordingly. Go to the home model file and create a new feature called save data. Then add a new member variable at the top called storage service. The service will be retrieved through the locator when the class is constructed. Then import your locator and import your storage service. To see that everything is working, we'll update our title before we call save data, and we'll update it again once we have finished saving that data. When using ScopedModel and you want your widget to be rebuilt in the UI side, you have to call notify listeners. So we'll wrap the setting of our title value in a function and we'll call notify listeners after we set the value of our title. Then in save data, we'll call set title and give it a string saving data. We'll perform the action on our storage service, so we'll call save data and await. And once that is complete, we will set the title to data saved. In the home view, we'll add a floating action button on our scaffold to call this function. In this onPressed callback, call model.saveData. And if you run the code now, you should see a floating action button pop up. Clicking that button should change your title to saving data, and when done, set it to data saved. And this is the base that the ScopedModel architecture will be built on. The dependency injection is set up, the view and the model binding is set up. Now we'll build out this architecture to handle all the common real-world scenarios. These are the things that our architecture will cater for. Shareable view state logic. We want to be able to create and develop multiple views with their models without too much boilerplate. We'll cover the navigation. We'll also create a shared modal busy indicator that is wired to our previously mentioned view state. And there's one common async scenario, which is requesting more data when landing on a new view. Let's start with view state management. If any of your views perform any async functionality, you have 4 default states that's associated with that. These states are idle, busy, retrieved, and error. All your views that contain async functionality will go through these states, so it's a good idea to build it into a base model to share amongst your views. In the lib folder, create a folder called enums, and in that folder create a file called viewstates. Create a new enum called viewstate and give it the 4 states. It's idle, busy, retrieved, and error. Go to your home model and create a new private variable called state. We'll expose this state through a public getter called state, and this property will return our private variable state. Whenever a property in the model changes that is bound to UI on the outside, you have to call notify listeners. We want to keep the calls to notify listeners to a minimum. So because of that, we'll only find notify listeners when the state value has changed. We'll change our setTitle function to be a private method called setState that takes in a viewstate. And in this function, we'll just set our private state value to the new state that is passed in. We can then change our setState calls to just set the title equal to the actual values. And then we'll add our calls to setState. We'll start by adding state.busy before we call our function. And when everything is completed, we'll call setState with the retrieved state. We'll add some UI into the home view to display that our state is changing. Create a function called getBodyUI that takes in a view state value. And inside this function, create a switch statement that takes in the state value. For the first case, when the view state is busy, we'll return a circular progress indicator. And when our state is retrieved, or for default state, we'll return text with a value done. Wrap the current text widget in a column, and as the first child of the column, return your getBodyUI passing in model.state. Set the main axis size to main_axis_size.min. Running this code and clicking on the floating action button should show you the busy indicator for 2 seconds and then the text done when that's complete. With the way we're going to handle our view states done, let's move on to creating multiple views and making it easier within this architecture. So as you can see in our current implementation, there's some boilerplate code associated with setting up a view. You have to create your view and then set your root to a scoped model, and then use the locator to get your model, and then set the root of your scoped model to a scoped model descendant and pass that as scaffold for your actual view UI. In code, that's actually not a lot to do, but you still have to do it every time. So what we'll do is create a base view widget that does all of this for us for each view. Head over to the UI folder and create a new file called base view. You can import material as well as the scoped model package. We'll also need to use the service locator. Then create a new stateless widget and call it base view. Each view will have its own model type, so we'll make this base view a generic class, and we'll make sure that the type extends model from the scoped model package. Then as the root of our build function, we'll return a scoped model of type T, and the child of our scoped model will be a scoped model descendant with the same type as our model that is passed in. And because each of the views has to build their own UI, we'll pass the builder directly from the UI into the scoped model descendant. So create a new private variable of type scoped model descendant builder and give it the same type, and we'll give it a name builder. Then create your base view constructor and give it a named parameter called builder. Then use constructor assignment to assign your private builder variable to the builder that you passed in. Then we can pass the builder down to the scoped model descendant, and the last thing we have to do is to supply the model with the same type passed in, and we'll get that from our locator. Then back in the home view, we'll replace all of the scoped model code, and we'll replace that with a base view and pass in the type of home model. So as you can see, the builder doesn't pick up that our model is of typed home model, and that's because we missed something in the base view. Go back to the base view and make sure that the parameter you are passing into the constructor also takes in a type. And when you go back now, you'll see that the code picks up that it's of type home model. I would recommend that you create a snippet or some kind of template for you to create your new views from. Since I won't be covering how to create snippets, I'll just create a new file called template view. And in this file, I'll put the basic code required to create a new view. You can just copy all the code from home view, and you can strip out everything that is not required for a generic view. We just want to leave our base view, and we have a center with text in the middle. To keep it generic, we'll make the text return the runtime type of the current widget. Next up is to create a base scoped model. We want all our views to be managed by the same state, so we'll move all of our state functionality into the model. Under scoped models, create a new file called base model. Import scoped model and create a class called base model that extends the model. Go to the home model and cut out all the state related code and paste it into the base model and import the view state file. We'll also move over the set state function and we'll make it public. Now go back to the home model and extend it from the base model instead of a model. And then change all of the set state calls to the public call instead of the private one. And make sure to import your model file. And with those changes, whatever model you extend from the base model will inherit all your state functionality, and you can bind to your state property from your UI. Now we'll create multiple views from our template view, and we'll tackle some navigation. Copy and paste your template view twice in the UI folder. You'll call the one view success view, and you'll change the class to success view. And the second view we'll call error view, and we'll change the class to be error view as well. Then we'll create the models for these views. So under scoped model, create a new file called success model and extend it from the base model. Then create a file called error model and do the same, extend it from the base model and call it error model. Just a few more changes. Go to your success view and update your base view model type that you pass into success model. There's one common scenario with navigation, which is to navigate after you receive a result from a service. To simulate this, we'll make the save data feature in the home model return a boolean. Then in your onPressed functionality, we'll make that function async. We'll store the result of the save data in a variable called result, and we'll await on that call. And then we'll check our result and we will push the new views using a material page route. So navigation is still done within the UI, and I think that's perfectly fine for this architecture setup. If the result is true, we'll navigate to the success view, else we'll go to the error view. The last thing we have to do is to register our new models with our service locator. So go to the service locator file and call the register factory function and pass in the new types. You'll pass in the success model and the error model. We'll just do a quick test, and If you click that value, you should see the loading indicator, and afterwards it should navigate to the success view. Next up is a shared busy indicator. This is not common since most apps usually have a busy indication per page. But because I did this for my client, I wanted to show you how to do this in case you also wanted to do it. Having a generic busy indicator for your app saves time in having to think of the design for your busy indication per view. So we'll set up a busy overlay that responds to the busy state in our base model. Whenever the state for the model is set to busy, we want the view to display this modal busy indicator. So under UI, create a new folder called Widgets. And I see that I forgot to put the views file in a views folder. So under UI, create another folder called views, and then move all the associated view files into the views folder. You'll have to go to the main file and update the location for your home view. So I imported the wrong view, but just make sure that you import the correct view and it's not the template view, which has the same name as home view. Now under the widgets folder, you can create a new file called busy overlay. In the description below, there's a written tutorial. Just open it up and copy the code for the busy overlay into the busy overlay file. We're not going over any UI building and it's not a very complicated view. Then go back to the home view and wrap your scaffold in a busy overlay widget. Make the scaffold the child of the busy overlay. And for the show value, we'll pass in a comparison of the model state and we'll check if the state is busy. This will make it so that whenever we set the state to busy in our model, this overlay will show. So to avoid any clashes in our app, head over to your template view and rename your class from a home view to template view. And if we run the code now for this app, if you press the floating action button, you'll see a busy overlay showing. This is significant for us because for any view where we want to show a busy state, all you have to do is wrap your widget in your busy overlay and pass in your model.state equals the busy state. Next up, we'll handle one of probably the most common scenarios that happens in a real world application. When you navigate to a view and you want to fetch more data based on information passed to that view and display that data when the function call is complete. We're not focusing on any UI, so what we'll do for this example is we'll pass some text to our success view and we'll have a feature that takes in that text, waits for 2 seconds and then duplicates that value for us. So go to the success model and add a new property called title and set it to no text yet. Then we'll add a feature called fetch duplicated text that takes in a string text. We'll call our set state value and set it to busy. We want our view state to be exposed in all the models that extends our base model. So go to the base model file and export the view states file. I don't know if this is good practice, but it helps a lot when writing the code. Then back in the success model, we'll await on a delayed future and give it a duration of 2 seconds. And when this delay is complete, we want to set our title to have 2 values of the text passed in next to each other. And at the end of everything, we want to set our state to retrieved. The next part we have to do is to set up our base view so that we can call this function only once when the view is initialized. For this, we'll use the init state override of a stateful widget. Go to the base view and change from a stateless widget to a stateful widget. You can do this easily by pressing Ctrl-Shift-R and selecting stateful widget. That applies to Visual Studio Code only. We'll create a function that will be called in our init state and that passes back the model to us. We'll call this function onModelReady and we'll assign this function in the constructor. Then we have to update our base view state to pass in the types that are required. We'll also update the create state part to return the same type of base view state. And we have to make sure that our type extends model in the base view state. And since we want to pass back the model in the init state, we'll have to keep it as a private member variable that we can pass back to the onModelReady call. So we'll create a private variable called model of type model and we'll set that equal to the type returned by the locator. Then we'll override the init state. We'll check if the onModel callback is null, and if it's not null, we will call the onModelReady function and we'll pass back our model. Now in the success view, we can pass in a callback for the onModelReady, and since it returns our model, all we'll do is call fetch duplicated text when the model is returned. We'll then pass it a title which will be passed into the success view through the constructor. Go over to the home view, and where we navigate to the success view, we can now pass in a title and you can give it whatever text you want. I'll just set mine to duplicate this text. If you run into any problems with a ScopedModel descendant builder, just make sure that you return the correct type for every type class that you instantiate. Go over to your success view and make sure that you return the model.title text. And to ensure that we are showing feedback on the success view, we'll wrap our scaffold in our busy widget. And for show, we'll just check if the state is equal to the busy state and pass that value down. Make sure to import the view state and the busy overlay. And if you click your floating action button now, you should see the busy overlay, and after it navigates, you should see another busy overlay popping up on the new view while it's fetching your async data. And this is where I'll end the guide. I am currently building out a new tool for app developers called App Skeletons. The goal of App Skeletons is to reduce the boilerplate code when setting up an architecture for your application. You can select your architecture and you can add all the views that's required for your app. You can also add additional functionality like login and sign up views, and it will generate an app based on the architecture that you selected that gives you a working Flutter project that you can start building on. The ScopedModel architecture on App Skeletons will be using the template that we laid out in this video. I am also planning to add the single app model approach for the ScopedModel architecture. App Skeletons is in its very early stages, and this is an MVP that I built in my spare time over the past 6 weeks. I would really appreciate it if you could check it out and maybe give me some feedback. I'm planning to add all the major architectures that is commonly used in Flutter, as well as the common services that are used by developers. Any feedback would be appreciated, and thank you for watching this video. Please like or share this video and don't forget to subscribe.